In this video, we will be looking at boat in the water problems. Now, I call those boat in the water problems because they all deal with a force that when you're traveling with the force, it speeds you up. And when you're traveling against the force, it slows you down. So the first problem that we're going to look at is, one day Shelby found that her plane could fly at 5 times the speed of the wind. She flew 396 miles downwind in 1/2 hour more than it took her to fly 132 miles upwind. What was the speed of her plane in still air, and what was the speed of the wind? Now, the first thing that I would do is take that first sentence and write an equation. She found that her plane, so I'm going to let her plane speed in still air, could fly at 5 times the speed of the wind. So her plane speed was 5 times the speed of the wind. Then the rest of the problem, I'm going to use what I call a dirt box to organize my data. And the reason I call it a dirt box is because its distance equals rate times time, so dirt. But the two things that we're comparing is downwind and upwind. So she flew 396 miles downwind, so that's the distance going downwind, in 1/2 hour more than it took her to fly upwind. So if this time is t, then this is going to be t plus 1/2. And she flew 132 miles upwind, so that goes in the distance upwind. Now, always for boat in the water problems, downwind, or when you're going with the force, your vehicle, in this case our plane, is increased by the speed of the force. And then going upwind, which is against the wind, the plane, in this case, is slowed down by the speed of the force, which is the wind. Now we can simplify these rates using this equation that I wrote right at the beginning. My plane speed, p, is the same as 5 times the speed of the wind. So I can plug 5w into my dirt box in place of p. So this is 5w plus w, which totals 6w, and that's what I'll be using for my rate for the downwind. And then 5w here minus w totals 4w, and that's what I'll use for my rate going upwind. Now, once all of the cells in the dirt box are filled in, then I can write my equations. We have distance, 396, is equal to the rate, which is 6w, times the time, which is t plus 1/2. In this equation, the distance, 132, is equal to the rate, which is 4w, times the time, which is t. Now this equation is something that I can simplify pretty quickly, so I'm going to do that. I'll divide both sides by 4. So the 4's cancel, and WT is equal to 33. Now I'll save that and use it in my other equation when I can. My other equation, I'm going to distribute my 6W through the binomial. So I have 396 equals 6WT plus, and then 6W times a half is 3W. Now I'm ready to use my value for WT. I'm going to substitute that right here. So I have 396 is equal to 6 times 33 plus 3W. Multiplying here, I have 396 is equal to 198 plus 3W. Subtract 198 from both sides, and I have 3W is equal to 198. Divide both sides by 3, and W is equal to 66. Now this is the speed of my wind. I can put that 66 back into this first equation that I wrote. P equals 5W. And so P is equal to 5 times 66. The speed of my plane is 330. Now if we need the units put on these, since my problem deals with miles and hours, my speed is going to be miles per hour on both of these.